Boy, this next one looks scary, doesn't it? So I want to find a particular solution, and they gave me the initial condition. So I'm going to have to integrate, because I'm going to have to go back up a level, and I'll need to separate and get x's and y's on one side. So let's start by moving this to the right. We'll see how that helps us. And then I notice that I have a y still on the left side that I'm going to need to move. And that should be easy enough. And I have an x term on the right. That should be easy enough. So it looks like if I divide both sides by y, then I'll make this pair go away. And if I divide both sides by negative e to the negative x squared, then I'll make this pair go away. And then, let's see, since this is a negative, I'm going to move it up top. So now it'll be positive x squared. And on the other side, yay, I have a single denominator. I will be able to separate those. So now I can integrate, because I got all the x's together, all the y's together. And let's work with the right side for a moment, because I would like to split those. So I'd have y squared over y and 1 over y. And of course that y squared over y is just going to shrink to a y. So when I take the antiderivative of that, I'll get y squared over 2. And on the other side, I'll have natural log of absolute value y. And then we could put the plus c over here. Now on this other side, well, I don't like having bling on my e. So let's do a u substitution and see how that helps. And then I go and check to see if I have all of that. And so I notice I have the x and the dx. I'm going to need a 2, and I don't need that negative in there. So I'll slip a little 2 in there, and a 1/2 out in front. So I'm really doing this integration negative, because I brought the negative out, and then e to the u and du. And so when I take the antiderivative of that, I'm going to have negative 1/2 e to the u. And now that I'm done integrating, I'm ready to substitute in my initial condition that says x is 0, and when x is 0, y is 1. So I'll put 0 in for the x's. Oh, oops, I forgot to substitute back in here. This should be negative 1/2 e to the x squared. And I didn't do any u substitution on this side, so it just stays the same. So now if I plug in 0 for x, going to have to turn your head sideways. It's going to be negative 1/2 e to the 0. Of course, that's 1. And I'm plugging in 1 for the y, so I'll have 1/2 minus natural log of 1 plus c. And e to the 0 is, of course, 1, so the left side is negative 1/2. And natural log of 1 is 0. And if I subtract 1/2 over, I'll end up with c equals 1/4. So, oops. My particular solution then okay, I'll admit, sometimes I struggle. That should be c equals -1. Right? -1/2 minus 1/2 is -1. I'm so silly. So what that gives us is -1/2 e to the x squared equals y squared over 2 minus natural log of absolute value of y minus 1. And I could do some manipulating. It's going to be really tough. Not going to be able to get those y's by themselves. Typically I'll have c on the x side, so if I move that over, -1/2 e to the x squared equals y squared over, oops, sorry, plus 1. Plus 1 equals y squared over 2 minus natural log of absolute value y. If I don't like the fractions, I could multiply everything by 2. Just thinking of some other things that I could do. So I would have negative e to the x squared plus 2. And on the other side, I'd have y squared minus 2 natural log absolute value of y. Again, where I stop really is dependent upon the multiple choice.